Hello, good morning, good afternoon, everyone. Welcome to this showcase session organized by Forum Europe for SES, the satellite company. I'm here standing, or actually sitting, with my colleague Alexander Gertz from Luxembourg. We are going to present you our cloud strategy. You will have a video for 35 minutes with a discussion between our colleague Sergi from the Cloud Strategy Department in SES and Eve from Microsoft Azure. They will explain how the two companies can benefit from each other. Microsoft from our coverage, rich options and possibilities all over the world, and SES from our integration into the cloud. You can, of course, post your questions in the chat. We will be happy to try and answer them during the video session, but we will have an extra 10 minutes to answer further questions directly. Are you ready for the video? Let's go for it.
Welcome, everybody. Eve and I are looking forward to sharing with you the benefits of cloud networking with satellite communications. And we have a presentation and an overview for you that we're going to walk you through. It's a little bit about the market, what each company is doing in this area, and then the synergies and benefits, obviously, of the combination. So I'm going to jump to the next slide. Before I jump in, Eve, anything you want to say?
No, nice to meet you all. So just to introduce myself, I am a program manager in Azure Networking and running the overall global network for Microsoft. Yeah.
Great. Thank you. So the first slide here is really to share with you the proposition, if you will, of the cloud in general. And so one of the things we look at in the IT marketplace is, in the past, you could buy a system for your on-prem IT requirements. It can be really good. It might not be inexpensive, might not be deployed very quickly, can't adapt with your needs. And sometimes you can get some of these capabilities and benefits with your investment, but with the cloud, the benefit really is all three of these. Something that's state-of-the-art, inexpensive, designed for your budget, and can be quickly deployed and modified and adjusted as the business evolves. Really gives your business or enterprise that agility over time for your workloads. So that really is the key proposition and why the cloud is adopted so well. And Eve, I saw recently in the analyst reports from Microsoft, adoption is really increasing. Maybe you can speak to that a little bit.
Yeah, sure. In fact, there's lots of underlying drivers behind the cloud, right? What I mean by that is usually we see customers like moving assets to the cloud to leverage like unlimited compute resources, right? But then when you go beyond that, you can leverage the cloud concepts to the sensors you have in your company or to your local devices. You can even go beyond that by deciding to offload some of the compute capabilities at the edge of your network. And now if you span the compute capabilities across the cloud, the big cloud, the sensors, the devices on the edge of the network, now on top of that, you can leverage some cutting edge technology like AI type of technologies that will connect to all of these systems together to bring you intelligence. And at the end, it's really all about bringing, using technology for allowing business transformation. And that's really what the cloud is about. It's about using technology to allow for business transformation. That's all the idea behind. Yeah.
That's great. Thank you. The next slide is enterprises sometimes are challenged to get that transformation across their complete enterprise if some of their locations aren't where connectivity is readily available. And so that idea of a uniform experience and benefit of that cloud transformation is difficult if some of your operations or assets are moving, remote locations, or in places where the network might have issues. So the objective is resiliency across the network so that everybody can benefit from that cloud platform. We've noticed that and we've had customers talk to us about running legacy systems where their network is less reliable versus adopting the cloud. And that's very difficult and costly to manage, is our understanding. So working with Microsoft, offering those combined benefit of solid connectivity with the cloud is addressing those issues, is what we've understood. There's certain industries, and I'm going to move to the next slide here, that lend themselves, if you will, to connectivity and cloud services. So kind of walking through them for you a little bit. Obviously, the government with its remote and temporary operations sometimes has lots of assets that are moving, needs connectivity for them to have mission critical information come back to the cloud. Maritime, commercial maritime crews, all of them are looking for connectivity to operate those systems more efficiently and benefit from those applications. The energy sector and the complete value chain of the energy sector, from the exploration, to production, and to distribution, is looking for that kind of connectivity. We mentioned Aero. But one of the key ones we also tend to talk about is just the digital divide. There's communities that are just in remote areas that would benefit from this. And so this is an area that the two companies saw as an opportunity and are working together to find ways to add those services, both the connectivity and the cloud benefit. One area that we talked a bit more about on slide 6 here is when we've been to visit customers and they see someone from the satellite industry, they say, "Oh, great, someone who can solve all my problems. Tell me about your IoT direct asset capability, your Earth observation capability, and your connectivity, your communications capability." And we say, "Oh, well, satellite industry, you have each is a separate framework or format, and there's several operators in each one of those categories." So we realized that maybe there's a better way to sort of integrate some of those systems. And so more interoperability, more virtualized systems, less proprietary equipment on the ground is an area of opportunity that was identified by Microsoft. And Eve, maybe you want to complement that.
Okay, indeed, yeah. The value of virtualization here is that you have fragmented technologies across multiple layers. You can combine that in the cloud to kind of standardize that. And that's all the value of the cloud is, like, you can bring functions to the cloud across all these different sets of technologies. That's what the cloud is about. Yeah.
In fact, in this one, we developed what we thought about. There's a scenario where an IoT sensor might say, "Hey, we have a high temperature reading. Maybe there's something going on in that asset." An EOS system could take an imagery of it and say, "Hey, it looks like there's a plume of smoke." And then the communication systems could light up the video or actually support the team that shows up to repair it in a remote area. So that sort of working together is sort of one of the scenarios we were contemplating.
And it goes really back to this concept of business transformation, because now you bring things together end to end. So it's not only about connectivity, it's not only about IoT, but in the scenario you just explained, it's really about providing an end-to-end scenario on orchestrating and automating that logic using cloud assets.
Exactly. Thank you. So moving along. So as I mentioned, the companies have been working together, and we want to share more about what Microsoft and SES have been doing in the area of cloud and satellite communications. Eve's going to start off with an overview of some of the Azure activities in this area. And I'm going to jump to slide 9 for the team there. Thank you.
So for Microsoft, it's kind of straightforward. Our goal is to make sure that wherever you are on the globe, you have access to the cloud. That's our charter here for the networking team. So obviously you need lots of fiber. As you can see here, there's lots of fibers. We keep deploying fibers across the world, and that will not stop. In that map, it's a mix of what we call dark fiber, own fiber, and lit waves across the world. Each blue dot here is either a data center, which is about 520 megawatts type of buildings to host all the compute, or an edge or edge pop. The edge pop is where we interconnect with other networks, right? So as you can see, the established markets are extremely well connected, but you can see places in the world that are a bit far away, whether you are crossing an ocean, Atlantic, Pacific, and whatnot, and some remote areas in the world, but don't have to go so far away. Even in the US, you have lots of remote areas where we need stronger connectivity. So it started with the global network. So just to zoom into one of the blue box here, next slide. If you zoom into the blue box, basically this is what you get. A blue box, the blue dot in the map is composed of buildings. And a collection of buildings is grouped into availability zones. And that collection of availability zones is defined as an Azure region. And that goes up to, as I said, 520 megawatt type of location. It's pretty big. It's kind of the size of a city from a power perspective. And the next step is, of course, to connect this Azure region to outside world. So we connect that to an edge POP. An edge POP, the purpose of the edge POP is to interconnect with local telcos, carriers, but also allow enterprise customers to have a private access to the cloud. And that is referred here as Express Route. So Express Route is our offering to support direct private access to the cloud. When I say private, I mean you talk about your private IP space. You can expand your on-premises network to a virtual network in the cloud. So that's what this blue dot I had in the map. This is what this is all about. So,
if I could, could you share a little more about how much that previous map has been expanding over the last year or two?
Yeah, I think we did the same type of presentation last year, and I had 54 regions. I think now it's 58. The number of edge sites, we are at a big pace. So just because we want to stay close to the customer, each time I bring an edge somewhere, an edge POP, I bring the fiber with it. So I really stretch the network to be as close as possible to the end customer. So if I can be within tens of milliseconds away from the end customer, it's a win for the customer, because it's much easier to expand its local network to the cloud and build an overlay on top of our network. And that's kind of the scale. So we have about I think around 170 POPs today worldwide, and it keeps growing. Just in the spirit of have better performance, reduce latency, and whatnot. Having said that, if you have a ship or a cruise in the middle of the ocean, there's no such fiber, so we still have work to do to connect. And this is
that brings us to the next slide. Yep.
Exactly. So this is where what we introduced last year as Express Route for satellite is exactly about that. So we thought, okay, the customers, whether it's a mine or an oil rig or a cruise or any kind of remote operations, they still want to use the cloud, as I explained in the beginning, whether it's IoT, compute, AI and whatnot. They still want to use it. Now, they can do it offline. So we have edge solutions that will allow the customers to run it offline. But still, at some point, you need to connect back to the cloud in a private manner. So we said, okay, the partners who can do that are satellite providers. You enable connectivity across the globe. So we said, okay, let's interconnect our network with the satellite provider's network. By doing that, I will bring fiber between a ground station or gateway or teleport, depending on how you call it, between that location straight to our network. So to make sure that you are always one hop away from us, so there's no hairpinning of traffic around the world. So we take the shortest path to our cloud. Once you do that, now on top of that, we add Express Route. So you, as a satellite provider, you can sell private connectivity to your end customers. So if I am in my oil rig or remote operations, I can still connect to my virtual network in the cloud, commercial cloud or gov cloud, using a private IP space, and without sending the traffic to intermediate networks. So there's no transit between the two. We have a straight access to the cloud to make it secure, on direct. And that's the value prop behind express route for satellites.
And the goal is to avoid sort of the variability and maybe security concerns you might have in a public network, is my assumption.
Absolutely. And by having that direct interconnection, clearly we want to make sure that, you know, if you are in I don't know, in the middle of the Pacific and you need to have connectivity from your ship, well, you want that traffic, you know, to land maybe in the gateway in Hawaii. In Hawaii, we have fiber, so let's take the traffic from Hawaii straight to our network and then to our closest data center, instead of, you know, sending the traffic to, you know, maybe the east coast of the US, because this is where the next hop would be for the satellite provider. So it's really like the idea is like minimize the distance, knowing that, you know, it's a long distance, you know, because it goes high in the sky. So we want to optimize each hop here in the path. Yeah.
You know, in the conversations we've had with many of the customers in these segments, understanding where their workloads are in Azure and their operations, and trying to reduce any type of hairpinning, any type of network that would actually add latency to it, is really the goal. And we've definitely got a lot of interest here. So yeah, that's great.
By the way, it's really about Azure. It's also about other, you know, workloads like Office. You know, Office 5 is heavily used, you know, in ships, you know, on cruise. So it's not. It goes beyond Azure. It goes to, you know, any kind of Microsoft cloud services.
Yeah, absolutely. We'll go on to a great example you have here.
Oh yeah, so this is the classic scenario, and that's like the most common scenario we see today with our customers. Our customers, they may be in location where the fiber reliability is not optimal. Okay. So how can we provide a reliable connectivity to the cloud? By doing that, you will see we introduce this concept of SD-WAN. Think about it as an appliance. That appliance is running in a remote location. Then in that remote location, we would, you know, pick the best path. So one path would be fiber, and the SD-WAN will look at the performance characteristics, the availability of that path, or maybe pick fiber by default. But then, if I have a fiber cut or any kind of low, you know, lots of packet drops on that path, the SD-WAN appliance could, you know, fall back to the satellite portion. And in that satellite portion, you can achieve pretty decent connectivity. You know, in that scenario with SES, we achieved almost 1 gigabits per second, which is significant for a remote site. But at the end, since we use express routes on both ends, it's totally transparent. In that setup, the fallback between fiber and satellite happens in 2 seconds. So within 2 seconds, I can fall back. The value of it as well is that small SD-WAN appliance here could be a virtualized function as well. It doesn't need to be a hardware equipment. It could run into a COTS machine, any kind of machine deployed in the remote sites. And we have the same equivalent as a virtual function on the cloud side. So that's really the classic scenario. It's very common that, you know, the fiber in some of the markets is not as reliable as we wish, and satellite is a great way to address that. It could be the reverse. If you're on a ship and remove that factory box here and replace that by a ship, the next level, and that's really the next level we see on next slide, is about, if you look at that end-to-end connectivity chain, value chain, you have that remote site talking to a satellite down to a ground station, and the ground station connected straight to Microsoft Cloud. In each of these layers, you run compute. You could run compute in the remote site. So lots of options here. We have Azure Stack Edge that can run in that remote site. The value of that is like you can process, you know, your IoT stuff locally, you know, only send what's required to the cloud, or, you know, you can bring functions, you know, in that remote site as well. So that's the value of running compute in the remote site. But in that connectivity chain, even what's running inside the ground station, you know, could be transformed into a virtualized functions and run locally as well. So now, by doing virtualization in each of these layers, whether it's ground station or in the remote site or in the cloud, you allow you choose where you want to run these assets, and it becomes very powerful because now you can add value-added services on top of that. In the case of satellite providers, if you need to position firewall or NAT or any kind of value-added services in that value chain, you can easily do it, and you can even decide where you want to run these assets, at the ground station or at the cloud, or even by positioning these value-added services in the remote site and managed by you as a managed service providers. Lots of scenarios. It could be AI, it could be pre-processing of data, it could be your own compute functions. It's all blurred now. The cloud is composed of a collection of edge sites, remote or not. Yeah.
What's interesting is this ecosystem that you've developed here. It enables other parties to bring applications and capabilities. So Microsoft also supports sort of a marketplace model, right?
Exactly, because we provide a platform for anybody to come in that platform, in that pipeline. So you can inject your own services. It could be you as a satellite provider, it could be your partner, it could be with multiple flavors. But at the end, it's all about providing more value to the end customer, because there's no reasons why the remote location should not have the same capabilities as a well-connected corporate organizations around me. So it's the same. At the end, we want to make sure that they all benefit from the cloud.
Absolutely, absolutely. We'll move to the next slide.
Yeah. So when we say here, move assets into the remote sites, or move assets or functions to the ground station and whatnot, it requires what we call a control plane to manage all these functions in a controlled manner, right? In a global manner. So this is all what we call DevOps. So DevOps means like you develop in the cloud, and then you decide where to deploy, but you manage all these assets in the same way. So there's no difference whether your code is running locally or in the cloud or in the remote site. That's that ecosystem we are building with DevOps, which is referred here as Azure DevOps. Now, in that connection, in that value chain, you have tons of software, you have tons of hardware equipment. We are talking about modems. Can I modulate traffic in the cloud? The answer is yes. Can I process my Earth observation, a pipeline in the cloud? Of course. Can I run AI on top of that? Even better. Can I orchestrate these services all together using like standardized process like ONAP? Of course. The value now, think about the scenarios that it opens, or that are open for you now. You could recombine parallel workflows, extend that story to other types of communication scenarios as well, because it's a highly adopted standard. Can I run or manage services for my end customers? The classic scenario is site acceleration, firewall, and even the SD-WAN scenario I shared with you earlier is like, it is a managed service. It doesn't need to be managed by the customer. It's something that can be offered by the satellite providers or by whoever is running that value chain. At the end, DevOps is key. That's important. We need a platform that can orchestrate these services together, and that's our value prop to the cloud. And of course, the glue between that is the connectivity, whether it's fiber or satellite. That's really the glue here.
Essentially, we talked about, in SES, we focus a lot about the satellite advancements and digital payloads for our O3b mPOWER development. The flexibility, the capability that's going to be deployed in the future has to be harnessed with systems that run like this, that are more agile, can be updated very quickly, get the features and functions of the satellite in the ground system. So the collaboration here is key between us. And in fact, I have some more slides about that coming up. Eve, thank you. I'm going to share a little bit around where SES is in its cloud adoption and transformation. And by all means, you're welcome to ask questions as we go through it. So similar to you in terms of the global scale and coverage that you're seeking with Azure's network, SES seeks the same with its satellite operations. We have two fleets, GEO and MEO systems, with ground systems across the globe. We've done some coloring here to give a sense of the difference. So the GEO system gives over 99% of the world's population coverage. The MEO system's more along the equator, plus or minus 50 degrees, and giving that high bandwidth, low latency capability that the MEO system is known for. The key thing is we're interfacing this network with Azure. So we've done it in each region, and that allows our customers in each region to use our system to connect to Azure. And that's been one of the key propositions. SES is progressing like any other venture enterprise in terms of its cloud adoption, starting from the right here in terms of our core operations. We've been adopting, as you mentioned, productivity tools. Office 365, you mentioned Dynamics is coming on board, Power BI. So these things are being deployed within SES today. We also are implementing automation orchestration in our backend so that we can actually do network services and provisioning much more efficiently and quickly. So we partnered and we've announced the work with Amdocs, and this system will run on Azure as well. And that will also give us the ability to offer those virtual network functions that you mentioned, like an SD-WAN, like a load balancer, monitoring, security, all those services will now be available on our network. The ground system development, we're key to our O3B mPOWER build out. So we're working with teleport partners to expand the global coverage for O3B mPOWER. And as Eve mentioned, the virtualization of the platform is really key. So that's something we're developing as well. And that involves both the RF side all the way through the chain and into the modems and into the cloud or network side of all that is being considered and evolving. We want to connect our systems to multiple clouds. Oftentimes, the customer drives the cloud decision. We want to make sure we can support that decision. But the key thing here is to think and sit with the customers around their future requirements, the outcomes they seek, and look at an architecture that takes advantage of these future technologies that are in development. So instead of just asking for a link today over satellite, they can say, well, what's the potential? What's the possibility? And using these that you mentioned, an ecosystem or a platform, we can sit with them and say, here's the capability, and here's what we can do, and where are you going in your business? And mobile assets, things that are occasionally deployed and then brought back. That edge compute capability is also part of that we want to make sure that if a customer wants very low latency, wants something on-prem that can be operated just like it is in the cloud, that capability is there. So again, we're doing that segment by segment with our segment leaders. So that gives you a sense of where SES is in its process. Anything jump out at you here, Eve, in terms of what you're seeing?
No, I think it's important, the edge compute is key here because not all scenarios are okay with high latency scenarios. And there's physics, speed of light is speed of light. So being able to propose an end-to-end story for the customer to run, some of the functions locally and use in smart way, which, connectivity to use. And it could be also multi-orbits, in that scenario, I can see two paths, MEO and GEO, you can decide which one to pick, right? And it's all about giving choice. Yeah.
Yeah, it's interesting. Some of the cruise customer we work with, they have both systems, and depending on the application or requirement, they can switch between them. So I'm going to move to the next slide to give you a feel for that idea, the benefit of the multi-orbit, right? The different services that can be provided, lower bandwidth access services to aggregating traffic over a higher bandwidth, all the way to the core network running on a trunk like O3B can provide. And obviously connecting it on the terrestrial side, either the public internet or to the private connections that you mentioned in terms of express routes. So all those are within the portfolio that SES is offering today, and giving that sort of flexibility, designing to what the end user is trying to achieve, whatever that asset, wherever it might be, that type of thinking. Moving ahead, we have we talked a little bit about O3B Mpower, but to us, this is really exciting. This is where the functionality and capabilities of the cloud now effectively are capable in the sky, in the space. You have a digitized payload that has flexibility in beamforming, has very high bandwidth, but it can be moved around, shifted. Beam sizes can be adjusted, so it gives a lot of flexibility to the use case and the user, and obviously with a very low latency service. So to us, we're really excited about that capability. But of course, you have to match that with the terrestrial side of that equation. And so I have a slide here around. Go ahead.
Just to talk about that one, for the cloud providers, this is key. When you talk about fiber, we usually talk in TBPS, and that evolution we see now in the ecosystem of satellite connectivity. Now you can see we are talking about GBPS, which is great. Like that's a big evolution. Now it opens the door to tons of new scenarios. Being able to talk about 10 Gbps, but moreover being able to allocate capacity on the fly in a more dynamic manner, it fits well with the cloud scenarios, because the cloud is about this elasticity aspect from a capacity perspective as well. So being elastic and adaptive, now using satellite connectivity is key. So it fits very well with the new generation of cloud scenarios. Yeah.
No, you put it very well. That high bandwidth, I mentioned just high throughput. Obviously, in your world, it's in terabits. Ours is in gigabits. But to go from the 1 gigabit capability of O3B current to this 10 gigabit and to be flexible, that flexible point, that's definitely exciting. Obviously, we also want to make sure that the ground systems advance along the way here. So we also spend a long time making sure that the antennas can be supported by multiple systems, multimodal, if you will. So if it's a moving asset, we want to make sure we have antennas that can support it, and terminals, but also fixed implementations that have maybe a smaller form factor. And the flat panel developments are also key. So we continue to work in that area to get to really dynamic sort of multi-orbit, actually flat panels that can do that diverse path. This is a key area of focus for us as well. But how to make all this work together is really the challenge, and that resource controller that is going to manage all these endpoints in a dynamic fashion and provision, simulate, and monitor how everything is performing and make sure we're delivering on the quality of service that people are asking. This adaptive resource control that's in development is really also the key technology, if you will, behind it. It'll also run in the cloud, which is exciting, and it'll provide the services that we're looking for. And again, this was part of the partnership that we've been working with Microsoft on. I don't know if you have any perspective on this one, but this is a pretty exciting part of the overall architecture.
It's really back to the elasticity aspects. It's like this resource control system is at the end, a massive control plane that is used to allocate resources on the fly. In fact, this is what we've been doing on the cloud. When you provision a VM, a virtual machine, a control plane has to allocate that VM to the right host and give you a resource. Now the same concepts are being applied to connectivity, being able to allocate that in a dynamic manner. The dynamic aspect is the most important. Yeah.
Well, let's we sort of covered sort of what Microsoft sees in terms of working in the space industry and what can be brought to bear in terms of making sure all the end users and customers benefit from the benefit of the cloud, no matter where they operate. So every asset really should be able to connect to the cloud. Our goal is to make sure that happens with our respective capabilities and services. And I want to thank you, Yves, for working with us on this journey, because we're early in our process, but we see so much opportunity here. And our customers are also giving us that kind of feedback. I think this is really going to be a unique feature to that combination of virtualizing these systems and making them much more flexible, easier to consume, easier to adapt when needed with the marketplace. So, any thoughts on your side?
It's really exciting. Lots of scenarios ahead of us. many opportunities. This is all for the benefits of our common customers. So this is great.
Excellent. Well, again, thank you very much. And now I think we're going to get ready for some Q&A. So let's get ready for that.
All right.
Thank you to Sergi and Yves for their presentation. I think a lot was said there. There were many information, but essentially the key message here is it's amazing to see how a major player like Microsoft is really engaged in including satellite in their ecosystem. Now, can I ask you a question first, Alexander? How does it inform us about the way satellite is getting integrated into the 5G ecosystem?
Yeah, thank you, Cecile. Let me do that. I guess one thing the audience has noticed probably is that the word 5G was not mentioned in this video. And yet it is at the heart of everything that we're doing here, cloud and 5G. 5G is really a recognized enabler of a digital transformation in society. Not just a mobile evolution, but an enabler of digital transformation. And as a consequence of that, it helps the transformation from, well, sorry, I'll try it again. The virtualization in particular, the evolution from hardware-defined elements to software-defined elements lend themselves very well for an implementation on the cloud. And as also the person from Microsoft, Yves Pitch, emphasized, when you go towards a cloud-based world, in fact, for a variety of reasons, including latency, the edge and everything that runs on the edge becomes an integral part of that. Now, what Microsoft and also some of the other cloud providers have recognized is that to reach and be able to develop the edge everywhere in the world, satellite is an important enabler of that. So what we see is 5G is leading the digital transformation. The digital transformation means elements of the network moving to the cloud, the network being distributed across the edge and more central locations, and satellite being part of that fully integrated connection from the edge back to the cloud. Another element, very important also for the integration of satellite into 5G, for instance, and again, Microsoft mentioned that also, is the fact that the overall orchestration of the network can take place in a cloud-based environment, and the whole orchestration also of the satellite piece of that can be very easily integrated through that. And that is something that we do also with the satellite network that we're implementing. Sergi referred to the O3B Empower network, the combination MEO and GEO. All of that is fully integrated and orchestrated in a seamless way also with the terrestrial network, with the resources allocated in a coherent fashion, and that is really how we are able to contribute also to the deployment of 5G, bringing the edge closer to the cloud anywhere in the world.
That's interesting what you're explaining now, Alexander, as a consequence of this strategy to integrate cloud into our networks and system. It is something which is happening now. It is not any more research or trials. It doesn't go through particular standardization bodies. It's industry-led. So basically, the main message, I think, here is to express that the satellite industry is getting integrated into the 5G ecosystem through many different channels. And our channel in SES is really industry-led through partnership with major players like Microsoft, correct?
Correct. And as you've seen, Microsoft is working with us, SES, also with other satellite operators, just like we as a satellite operator are working with different cloud players. And that really makes it into a very, very strong and powerful overall ecosystem. And 5G is being enabled and supported by that everywhere in the world.
Right.
And if I may, maybe as an example, we've done several demonstrations, trials, experimentations, also with MNOs on 5G. In the US, we've demonstrated interconnection of a 5G network with a major operator through our MEO network. They were very positive about the way it worked immediately as a sort of a backhaul function that was working perfectly for them. Also, the whole element of the virtualization and the network management and control, we developed that in various R&D projects, and we're implementing that for our operational services as we speak.
Good. Well, thank you, Alexander. I was turning to the audience to check whether there was any question, and I haven't heard from them. So I think we can probably bring this session to an end. As a final remark, I want to repeat that each satellite company has its own strategy, despite the fact that we are all together getting into integrated progressively into the 5G ecosystem. So I think it's important for the audience and the people in general to understand that we are not dependent, our industry is not dependent on one particular type of strategy and integration or through any specific organization or body. The 5G PPP, for instance, has been extremely helpful and supportive for us to research, test, make trials about how 5G can be integrated into the 5G ecosystem. Satellite can be integrated into the 5G ecosystem. Other initiatives which are better known are going through the 3GPP. There are additional bodies supporting that type of activity and integration. But the main message is really to say the satellite industry is ready and is doing it now. So we don't need to wait to get the satellite integrated into the 5G ecosystem. We're already here in the starting blocks and actually up and running a network that has all the functions and specifications of 5G. Thank you for your attention, and we wish you a good continuation of this conference. Thank you, Alexander.
Thank you, Cecile. Thank you to the audience.